Hi, I'm going to go with this review sheet for you. If you have any questions, feel free to email. Okay, so the first thing is place each number in the correct category, and we're breaking up the numbers into two categories, rational or irrational. So the first is rational, so I'm going to put the square root of 16 because that's the same as 4. 4 is a whole number or an integer. Then the square root of 20 is going to go under irrational. And that would be because 20 is not a perfect square. The square root of 15 would also go here because 15 is not a perfect square. Pi is irrational. It's a non-terminating, non-repeating decimal. 5.75 is rational because it's a terminating decimal. So when we look at decimals, we're looking to see whether they terminate, which is stop, whether they repeat, which means it's the same number over and over again, or whether they don't terminate or don't repeat. If they don't terminate and don't repeat, that makes them irrational. All fractions that are made of integers are rational. Now, if a fraction had, say, the square root of 3 in it, that would be irrational. Okay. The square root of 100 is rational because the square root of 100 is equal to 10. The square root of 3, irrational, non-terminating, non-repeating decimal. Square root of 36 is rational because that's 6. At 2.4, terminating decimal. 3.45464748, that is going to be irrational. Now, I know there's a pattern, but a pattern does not mean the same thing as repeating, and that does not repeat. Okay. Integers are a subset of rational numbers. Which numbers from the rational numbers listed are also integers? So the square root of 16 would be an integer because that's equal to 4, and 4 is an integer. Tenths, hundredths, 75 hundredths, not an integer. Integers are all the whole numbers and their opposites. So 8 over 13 or 8 thirteenths, not whole, not an integer. Square root of 100, that's an integer because 10 is whole. Square root of 36, that's an integer because 6 is whole. Okay, simplify the radicals. So the idea behind simplifying the radicals is you're pulling out anything that is rational from that, and you're using factors. So when I look at the 128, I'm going to break that down into 64 times 2. I chose the 64 because the 64 is a perfect square. So when I actually calculate the square root of 64, I get the whole number 8. So that would be 8 radical 2. 50, I can break down into 25 times 2. So that would be 5 radical 2. A number in front is called a coefficient, and coefficients multiply. The square root of 48, I'm going to use 16 and 3. The square root of 16 is 4, so 4 radical 3. And then, like I said before, the coefficients multiply. So 4 times 4 is 16, 16 radical 3. Okay? All right. Which set of numbers would the sum of radical 12 over 3 and 3 over 4 belong to? Well, 3 over 4 is 3/4, and this is rational. The square root of 12 over 3 is irrational. You can't divide the radical 12 by the 3 because the 3 is not under a radical sign. That's a normal 3, not a radical 3. So that's not going to simplify to a whole number. Okay. Remember, fractions are rational when both the numerator and the denominator are integers. The square root of 12, radical 12, is not an integer. Whenever you add an irrational number plus a rational number, it's always going to equal an irrational number. That's one of our rules. So you can say that. You could also use your calculator. So I'm just going to type this in my calculator for a second. Oh, I hope my battery doesn't run out while I'm doing this. I got the square root of 12. And then I'm dividing that by 3. And I got 1.154700,538, et cetera, which is irrational. And then if I add 3/4 to that, I get 1.904700538, which is a non-terminating, non-repeating decimal. Having a little trouble writing that, but that's that, which makes it irrational. So this is irrational. It belongs to irrational. And I gave you a couple of reasons. All right, so here we go. Whoops, a little too fast. All right, so when you're multiplying, they don't have to be like terms. So I'm going to do 3 times 32. 3 times 4 is 12, and 3 times 32 is 96. I thought it was 96, but I wanted to double check. Okay, so now I'm looking for a perfect square that 96 is part of, and I'm going to go with 16. So I've got 12 from the coefficient, and then 96 divided by 16, I believe, is 6. It is 6. Okay, so I chose the 16 because the 16 is a perfect square, and it simplifies to the whole number 4. And then 12 times 4 is 48, so final answer, 48 radical 6. And there's a few ways that you can do this. If you simplified first, that 4 radical 32 would be 16 radical 2. And then 16 times 3 would give you the 48. 2 times 3 would give you the 6. Okay? 2 radical 5 plus 3 times, and I'm breaking this down into 25 and 3. So this becomes 3 times 5 radical 3, which is 15 radical 3. And I'm going to add that to the 2 radical 5, which I cannot because the 5 and the 3 are not like terms. So that's actually all I can do. I cannot combine them any further. Okay? If the radicands, the numbers under the radicals, had matched, then I could have added them further. Okay? All right, name the most appropriate domain. So time recorded when a person runs a race. So time is continuous. So it's not going to be integers because there can be halves. But it would be positive because time's never negative. The number of books ordered. Well, I can't order half a book. So integers, but no whole numbers makes more sense because you can't order negative amount of books. Okay, number of pets owned. So you can't own half a pet, and you can't own a negative amount of pets. So I'm going to go with integers greater than or equal to 0. All right, so name the property used. So to go from here to here, I'm going to use the distributive property. So the first line, I'm going to write distributive property. Okay. Then I have to look, and it looks like the 2x and the 3 switched places. So that's switching of order. That would be the commutative property of addition. Commutative property of addition. Okay, so now it looks like the 2x was subtracted from both sides. So that's the subtraction property. A full name is subtraction property of equality. Okay, whenever you subtract something from both sides. All right, so now it looks like 15 was subtracted from both sides. So that again is the subtraction property. And again, the full name for that is subtraction property of equality. And then it looks like each side was divided by 4. So that's the division property or division property of equality. So remember, the properties of equality are the things you use to solve equations. So those are those properties. Okay, change from 6 feet per minute. So that's my start. And I'm going into miles per hour. So this is where I want to end up. So I'm going to go from feet to miles. there's 5,280 feet in 1 mile. And that takes care of that. Oh, so from minutes to hours, that's not so bad. There are 60 minutes in 1 hour. Now, you do want to pay attention to where you wrote the words. And maybe I can change colors. No, I can't. Okay, so I'm going to cross out the word feet with feet. I'm going to cross out the word minute with minute. And you notice I'm left with miles per hour. So now you multiply across. So 6 times 60, 360. 1 times 5,280 times 1 is 5,280. So 360 divided by 5,280. And that's going to be 0.068, and I'm rounding, miles per hour. All right, here we go. Change from one load for 15 minutes to cubic feet per hour. So one load in 15 minutes. So there is 60 minutes in 1 hour. And that's going to take care of the hour. And then it said that one load is 8 cubic feet. So I'm going to put the 8 cubic feet here. And I'm going to put the one load here. And you see, they had to give you that conversion because who would know what one load is? All right, so load cancels with load, minute cancels with minutes, and I'm left with cubic feet per hour. So remember, in the rates, whatever words come first, that's the numerator. Okay? So when I multiply the top, I get 480 over 15. So I have to divide. And that's 32. That's a nice answer. So 32 cubic feet per hour. All right. So, my suggestion with these is look at the words first and then deal with the numbers. Okay. So ounces cancels with ounces. Cups cancels with cups. Pints can't cancel. See right here? Contradiction. So I'm going to flip this one. And then it'll cancel. So that's what I would have to correct. So to correct this, I would do 1 quart over 4 pints. And that would correct it because then I could do pints with pints and I could do minutes with minutes and I would be left with quarts per second. And then you could calculate the number. Oh, look like that's it. All right. So hopefully this helps you. You have this review. You also have some Regents questions, and you can always go on Delta Math. And if you have any questions, let me know. Have a great time studying. Take care.